Okay, one form we already learned, the standard quadratic form. Was ax squared plus bx plus c. Now we're going to learn another form, and when it's in this form, they call it the vertex form. And it's easy to pick off the vertex just by looking at the numbers in when it is in vertex form. So let's take a look at this and see what we're talking about here. If you're given in this standard form here, or excuse me, vertex form, the vertex is simply the h and k values. And of course, as we said before, the x value of a vertex is the same as the axis of symmetry. Now, this a can just be a number, whether fraction or integer. If a is positive, the parabola will always be an upward parabola. And if a is negative, it will be a downward parabola. Okay, for an example, when you look at this problem, you can say, well, here's h, which is 4, and here's k, which is 2, so I can immediately know my vertex is 4, 2. Now be careful, because minus is part of the form, so this 4 is a positive 4, 2. So we have the vertex at this point, which is 4, 2. So we could plot that right now. And we know our axis of symmetry is the same as the x value of the vertex, 4. And we'll do what we learned in the last section as far as picking out points that are the equidistant left and right of the axis of symmetry. So I'm setting up my table with my calculation area to find y. So I just put in my function quantity x minus 4 squared plus 2. Well, our axis of symmetry is 4, so one right would be 5 and one left would be 3. So I'll choose the values 3 and 5. Again, this way I only have to calculate one of them because I know I'll have the same y value for both of those. And if I go 2 right and 2 left, those would be the values 6 and 2. If we put in 3 minus 4 squared plus 2, well, 3 minus 4 is negative 1. Negative 1 squared is positive 1 plus 2 is 3. And we'll have the same value if we plugged in 5. If we put in 2, 2 minus 4 is negative 2 squared is positive 4 plus 2 is 6. And we would get the same value if we plugged in 6. So we've got some coordinates we can go ahead and plot now. Three, 3, and 5, 3. 2, 6, and 6, 6. And we're done, and there's our parabola. So again, when it's in this form, it's just easy to quick go ahead and get the vertex by looking at what value is in for here for h and for k. In this case, it was 4, 2. Okay, let's try another one. Now, the vertex in this case, remember the form was this. Now, for this to be plus 3 here and to have the formula be minus here, the only way that that could turn into plus 3 is if this was negative 3. If we had x minus negative 3, which would be the same as x plus 3. So our x part is negative 3 for our vertex, and our y is simply 2. Some people, if that confuses them, they just look at this and say, well, for my x, I'm always going to take the opposite of this sign. If it's a plus, I'll make it a minus. That does not apply for the y. That it is whatever value it is. If it's positive, it's positive. If it's negative, it's negative. So if our vertex is negative 3, 2, our axis of symmetry is x equals negative 3. And as you're getting used to this, we'll make some tables. So we have negative 1/2, our function, quantity x plus 3 squared plus 2. Now to pick out our x values, let's go ahead, well, we can plot our vertex right now, negative 3, 2, which would be there. And our axis of symmetry we know is x equals negative 3. Now again, we'll do the same technique. One right of negative 3 would be negative 2. One left would be negative 4. Two right would be negative 1. Two left would be negative 5. And we'll do our calculations. If we put in negative 2 plus 3 is 1. 1 squared, negative 1/2 times 1 plus 2. Well, that's negative 1/2 plus 2, which is 1.5. And again, we know we're going to have the same value if we put in negative 4. If we put in negative 1, negative 1 plus 3, 2 squared is 4. So you have negative 1/2 times 4 plus 2. Well, negative 1/2 times 4 is negative 2 plus 2 is 0. And we'll have the same calculated value for negative 5. Okay, let's plot these points. Negative 2, 1.5, and negative 4, 1.5 right across from it. -1, 0, and -5, 0. So there is our parabola. Now you probably noticed some patterns developing from doing past problems. The negative, whenever we have a negative up front, that inverts the graph or turns it upside down, and the 1/2 made it wider. If you look at this next problem, well, we're almost in vertex form. If we just did one simple step here and subtracted 3 from both sides, we would then have y equals so your vertex in this case would be 2, -3. And your axis of symmetry would be x equals 2. So if we plot the vertex of 2, -3, and we know our axis of symmetry, the line that cuts the parabola in half, is x equals 2. Now you can make some predictions about this, and I'll let you finish this one on a table. Looking at this, from what you've learned in the past, it's positive, so you know it should be an upward parabola. And from what you also learned in the past, when you have a number greater than 1, like a 2, just as if it was in standard form, should make this a more narrower or steeper parabola. So you can pretty much approximate, even before you plug the numbers in, that it's probably going to follow a line like this. It's going to go upward and be somewhat narrower. You can go ahead and set up your table, calculate it, and see if indeed that is what you get. And with your vertex being 2, -3, and your axis symmetry being 2, pick numbers 1 right and 1 left, which would be 1 and 3, 2 right, 4 and 0, and calculate your points. Yeah, finish that problem off and see if you get what we talked about that we expected to get, an upward one that is a bit narrower. And that's it for vertex form.